All right, I hope everybody's rested from your field trip on Friday, and for those non-ties that went to Saturday as well, overnight. You had a good time. This is the first video of Chapter 6, Solving Systems by Graphing. Okay, we're going to graph two or more linear equations, and we're going to have different types of answers. Okay, so let's get right into it. Okay, so we are going to graph both of these. Remember, it is a good idea to always have things into slope-intercept form. Okay, remember that's probably the easiest way to graph them is from slope-intercept. So I'm just going to go ahead and make a graph with 5 values on each of the axes. Alright, so I'm going to do graph number 1 like this. So I got +2, and the slope is up 1 and over 1. Okay, now, just as a suggestion, it would be to always do your slope several times. As you're trying to do this, it's going to make it easier to find the location where the two lines cross. That's the point. That's what we mean by solving. We're trying to find out where the lines cross. Now, not only can we go up one and to the right one, but we can go down one and to the left one. Okay, so down one. All right, I think that should be good enough. We're going to connect them with a perfectly straight line because that's all I draw. Okay, now this one is line number 2, so we have -2. This one tells us to go up 3 over 1, up 3 over 1. Okay, so I just found the location where they cross. So what I'm looking for is this. That would be 2, 4. Okay, so what this point means is this is the intersection of those two lines. This is the answer that I can plug into both equations and get both of them to be true. Okay, so 4 is equal to 2 plus 2, and 4 is equal to 6 minus 2. Okay, so I just plugged in x. 2 times 3 is 6, 6 minus 2 is 4. I just plugged in x, 2 plus 2 equals 4. So that's what we're doing in this section, is we're trying to find where the lines cross. Okay, let's look at another one. Okay, so I'm going to do this time I did 6. Okay, so this one is at +4, 1, 2, 3, 4, and then it's got a slope of up 2 over 1. Okay, so I'm going to go down 2 to the left 1, down 2 to the left 1, down 2 to the left 1. And there is my graph for that one. And then I've got this one, +2. This one tells me to go up 1 and over 1, up 1, over 1, up 1, and over 1. But I notice I'm getting further away, so now I'm going to go the opposite direction. Down 1 and to the left 1, down 1 and to the left 1. And what I see is two lines that cross. Here is where they cross, and that ordered pair is -2, 0. So once again, -2, 0 plugs in and makes both of those true. Alright, now, writing a system. So they give you a word problem, and your job is to come up with the two equations and then to determine after how many months did the alligators weigh the same. Okay, so here's two different alligators over a period of 12 months. First one weighed 4 pounds, and it was 1.5 pounds per month. So this one, alligator number 1, is going to be this equation. Okay, I'm going to change 1.5 into 3 over 2. And it was already at 4. Okay. This alligator over here weighed 6, and he increases 1 month. So y is equal to x plus 6, so 1 pound per month. Okay, so those are the two equations. And then you go through the process of graphing it. Okay. Now, we have specific types of answers. We have ones where they cross at one point, We have ones where they cross constantly, and we have ones where they never cross, right? So what we want to do is we want to put these two into slope-intercept form. This one already is, so I have to solve this one. 2y minus x is equal to 2, so I'm going to add x to both sides. So 2y is equal to x plus 2, and then I divide everything by 2. So y is equal to 1/2 x plus 1. So what do you notice about this new form of the equation and the second one? That's right, they're the same. So what I'm going to do is I'm going to graph them. Okay, so let's just do 2 on each side. Okay, so I graph 1. The slope tells me to go up 1 over 2 and go down 1 and to the left 2. And that's the graph of the line, but they're both the same. So this one has an answer of infinitely many solutions. Since both equations turn into the same equation, then that means every number works for both of them. Okay? What happens here? What do you notice about these two equations? Okay, hopefully you guessed the right answer. Let's just go to 4 on either side. Okay, so we're going to graph the first one. 2 tells us to go up 2 to the right 1. This one is at -1, tells us to go up 2 to the right 1. So this line looks something like this. And this line looks something like this. Oh, look at that. They're parallel. So this one says they never cross. So we would write no solution. Okay. Two lines that never cross never have an answer. Okay. Okay, summary. They cross, one solution. Same line, all solutions. No solution, they're parallel. Practice. Give them a try, see how you do. All right, I'm out. See ya.